Hello students, today we are going to discuss the electric field due to point charge and electric field due to system of charges and what is electric dipole. In this video we are going to concentrate on this four topics. First, let me go for my presentation. Now we will study the concept of electric field. So the electric field, how it comes, before we rush into this topic, electric field, we should know what is Coulomb's law. So Coulomb's law we already studied in our previous class that if there is two charges, if they are separated from a distance r, then there exists an electrostatic force. That force will be directly proportional to this product of these two charges. So that means Q1 and Q2. And it will be inversely proportional to the square of distance between them. And if you combine these two equations, we get that as F is direct proportional to Q1 by Q2 and inverse proportional to square of distance between them. Then we introduce one constant, that is K, to remove that proportionality. So we'll introduce the proportionality constant K, so that will become K Q1 Q2 divided by R square. This is the magnitude wise I am writing the Coulomb's law. So this K, again we have given that value as 1 by 4 pi epsilon naught, where this value is given as 9 into 10 to the power of 9. And again we introduce one more constant here, it is epsilon naught, that is permittivity of space. This thing in detail we have discussed in our last class. So what is epsilon naught, what is the unit of epsilon naught, what is 1 by 4 pi epsilon naught, what is the unit of 1 by 4 pi epsilon naught, we have discussed. Now, how this force exists in a space? To existence of this force, we need to know what will be there around this charge. What will be there? What is that electric influence will exist around this charge? We should know that. Suppose, let me say that I have a charge. I have a point charge in a space. So I am locating the point charge here. So I have some point charge here. So it is charged. It is a charged body which is having a charge. Let us say that it's having a charge Q. Okay, it is having a charge Q. So this is producing some electrical influence around this charge. It is producing around its surrounding, it's producing some electrical influence. That electrical influence will make any other charged body, if it enters to that electrical influence space. So let me say that this point P, if some charge comes to this point P, so that charge which comes to that point P will get influenced by this charge. It get influenced by this charge. The meaning of the influence is there exists a force between them. So that means there is something at this point P. That something we will name it as electric field. All right. Now we can define in that manner. I will bring the point. I'll bring to the point P. I will bring a charge. That charge I will name it as Q naught, which is again named as a test charge. Why we name that as a test charge means I'm bringing that to check whether there exists an electric field at that point P. To test that I'm bringing, that's why we named as test charge. So that is named as Q naught, and this is producing the electrical influence around it. So that's why we will call it as source charge. That electric field at the point P, now it is defined as the force experienced by unit positive charge unit positive charge positive test charge placed at that point. One more thing very important, without disturbing the position of the source charge, without disturbing position of source charge. That means we have considered that unit positive charge, that unit positive test charge should not disturb the position of the source charge. If you disturb the position of the source charge, so what you're defining, it will be in a problematic situation. So that should not disturb the test. That's why the test charge should be, that Q naught should be very smaller. Very small means such a way that it's small enough that it will not disturb the position of the source charge. It should be very small enough. It should be very small enough that it won't disturb the position of point charge, position of source charge. So that means I can define, like, by based on the above definition, the electric field can be defined as E vector is equal to F vector divided by Q. That means force experienced by the test charge. That's all. That is the meaning of the electric field. And the direction of that electric field E is same as F. So the direction of the force and direction of the electric field is same. So magnitude wise, you can write the E is nothing but F by magnitude of F divided by Q naught. And by considering that, so that means it should not disturb that unit positive charge which you have taken to test that. It should not disturb the position of the source charge. For that, without more precisely, you can write using the mathematical techniques. So that is, I can write E is equal to, E vector is equal to limit Q naught tends to 0 F vector divided by Q naught. The Q naught tends to 0 is very small. So this is more precisely using the mathematics, you can write that electric field. Now, we need to know what is the SI unit of this. SI unit of electric field. So that SI unit of electric field, you can define force SI unit is Newton and charge SI unit is Coulomb. So you can say that Newton per Coulomb. Or also you can access volt per meter, so that you will learn in the next chapter how it comes the volt per meter. So these are the unit. And dimensions, you can write it. So force dimension divided by charge dimension, so that you can do it. Now, I will go for another important thing is, let us see how can we express the electric field of a point charge. Electric field into a point charge. I'll go for another slide. Field into a point charge. Yeah. So electric field into point charge. So meaning is the same way. Let me consider first point charge. This is my point charge. I'm placing the point charge at the origin. So I place this point charge, which is having the charge Q. So this is having the charge Q, and I will name this is the source charge. I positioned it O at the origin. So I position that at origin. Then I will choose a point P here. At this point, I need to find out what is the electric field of this source charge, which is the point charge. So that is Q naught. That Q naught, what I do, the trick is, at this point I would find out, I assume that I am placing that Q naught. That Q naught is test charge. I will place a test charge to find out whether the electric field exists or not. Okay, that Q naught is placed at point P to test the electric field of source charge Q. Okay. Now we know the force between this source charge and test charge that is given by according to Coulomb's law. Coulomb's law. Force between these two charges, that is the force on Q naught due to Q. So that is given F is equal to 1 by 4 pi epsilon naught Q into Q naught, and the distance between them, let us say that it is R. So I can say that magnitude I can write like this. Now let us come back to the vectors also. The vectors, the force between these two, force on Q naught due to Q will be in this direction. Let me change the color. It will be in this direction, the force. This is the F which exists. This direction, let me name that as from O to P, that vector, I will name it as R cap. That means I just introduce here R cap, it takes care of the direction. So this becomes a vector because R cap is from O to P and the force is also from O to P along the OP. You can also write that along OP. Direction is along OP. Now, by definition of the electric field, we know that. So electric field, we know that F by Q naught. Okay. F is given here already 1 by 4 pi epsilon naught Q naught divided by R square, and this R cap all divided by Q naught is there. So Q naught goes, you can write the electric field now. Electric field will be 1 by 4 pi epsilon naught Q by R square and R cap. So as I said that electric field direction and the force direction will be in the same, they will be have the same direction. So this is the electric field due to a point charge. All right. So once it is asked, you need to write the diagram properly and you need to write why we are considering the Q naught at a point P. The point Q naught we have taken at a point P such a way that Q naught is very, very small. We took that Q naught to test the electric field at the point P. We assume that I am placing a small unit positive charge, and we will by the Coulomb's law we will write the force between them and we will get it. And also the thing, observe this equation. The electric field of a point charge varies inversely proportional to the R square. The electric field varies inversely proportional to R square. That means as you go away from the source charge, the electric field goes on, decreases in the square of the distance. So if you are too much away from this, the electric field will be reducing. If you are near to it, electric field will be more. It can be visualized in another manner also that we will come across. It can be visualized in the form of flux, in the form of the electric field lines. So we will discuss that later stage. Now, once we have discussed this, now we need to see that I have taken only one point charge. If there are a system of point charges in a space. So let us do that. Okay, so let me clear up this. I have taken here, observe this diagram. So in this case, Q1 and Q2 is already there. The position R1 vector, which I have written here, is position vector of Q1, and R2 vector is position vector of Q2, and R vector is a position of point P, position vector of point P. Okay, observe this. I have Q1 and Q2 in a plane of xy, and Q1 is having a position vector R1, Q2 is having a position vector R2. Then I am taking a point P. At that point, I want to find out what is the electric field. So I have to determine how to determine electric field at point P. So for that, I should first think that I should imagine that I have placed a test charge, that is Q naught, at point P. I should assume that I have placed a Q naught. Then first, foremost thing, what you need to find out, what is the electric field at a point P due to Q1. And also I need to find out what is the electric field at point P due to Q2. Then once you find out individually electric field of Q1 at point P, electric field of Q2 at point P, then we are going to add them vectorically. So this is called, we already studied, this is called superposition principle. So that superposition principle we need to apply here to find out the electric field of a system of charges. So first thing, let us find out what is the force. Force between our force at our force on Q naught due to Q1. So that is, let me write that as F1. That F1 vector is 1 by 4 pi epsilon naught Q1 Q naught divided by R square, and the direction R square is here is R1P, that is the magnitude of Q1 charge to P, that is the distance from Q1 to P, R1P. And if I write that as R1P cap, that takes care of the direction. So this is first equation. Then E1 you can find out. E1 is nothing but F1 divided by Q naught. So you remove the Q naught from the above equation, that is 1 by 4 pi epsilon naught Q1 divided by R1P square and R1P cap. So that is the electric field. This will give you the electric field of Q1 at point P. Now I need to find out similarly, E2 I can write it as 1 by 4 pi epsilon naught Q2 divided by distance from Q2 to P is R2P. So that R2P square and R2P cap will take care about the direction. So this is our equation 1, E1, and E2 I got it. Now according to superposition principle, principle, so it says that net electric field at the point P, E net at point P is nothing but electric field of charge 1 at point P plus electric field of charge Q2 at point P. So you should add them vectorically. This is the meaning of superposition. You should add them vectorically. So let us see how to add them vectorically. So look at here, very important. At the point P, the direction of the E1 will be like this. That means F1 and E1 will be the same. Because this is Q0 is positive, Q1 is also positive. They will be repelling. Repelling will be F1 in this direction. F1 in this direction means E1 is also in the same direction. Now look at what happens to the Q2. Q2, the electric field, the force, the F2. F2 means the force on Q0 due to Q2 will be in this direction. This is the what we say F2, and E2 is also in the same direction. Both are in the same direction. Now the resultant of these two will be like this. Resultant of this two will be something like this. This is the E net. Means you should add them vectorically. You should add them vectorically means you should find out what is this resultant vector, that is the E net direction. So for that you should use the parallelogram of vector addition. Parallelogram of vector addition says that E net is equal to E1 plus E2 vectorically. Okay, so those things you need to find out. Or if you know magnitude wise, the magnitude of E net will be root of, you learned in the 11th standard, E1 square plus E2 square plus 2 E1 E2 cos theta, where theta is angle between E1 vector and E2 vector. So you will be knowing the theta, and you will be knowing the magnitude of E1 and E2. You can calculate the magnitude of E1 and E2. So then you can substitute in this equation and you can get the magnitude of the net vector. And also you can get the direction of the net vector. Once you get this one, the direction is nothing but the alpha, which is, yes, if you name this as an alpha, then I can say that you can use the again trigonometry and you can get the alpha also, direction also. We will take up some problems for this in the next class. So this is the way you can find out the system of point charges. Suppose you have too many charges, so you can apply. There are so many charges, like more than 2. So you have now n number of charges. Then you can apply this. You can write the equation in this manner. So E vector, that is E net, will be the electric field of the system of charges, that is 1 by 4 pi. 1 by 4 pi epsilon is constant. Then you can write it as summation of I is equal to 1 to n qi divided by r vector minus ri vector q magnitude into r vector minus ri vector. So this is the way you can write. Or else this another way you can write it as is equal to 1 by 4 pi epsilon naught summation of I is equal to 1 to n qi divided by, this is the you can write it as a 1 I ri. So you can write it just an r minus ri whole square, and this can be written as r cap minus ri cap. So this is the way you can write it. So this three things I have discussed now. What is the electric field due to point charge, and electric field due to system of point charges. In our next class, I will discuss the dipole. So what is the dipole? What is the electric field of dipole along the axial point, along the equatorial point? Okay, so we'll discuss the next class. Thank you.